When you hear the word laser, what comes to mind? Is it those space guns that shoot beams? Perhaps those alien light that sucks you in their spaceships? Perhaps those deadly beams that movie villains use to threaten humanity? Well, we really can't blame you if you think like that. But what really is a laser? Well, besides the word sounding like an alien invention, it actually is not that complicated. And today, we will find out all the bits and do's that make up a laser and how it's implemented in our everyday lives. Laser means light amplification by stimulated emission of radiation. Such a mouthful, isn't it? Well, this means the production of light through the production of protons. But how are protons made in this scenario? This works by sending electricity to a gain medium from a power source called a pump, providing the electrons of the said medium energy to absorb, making those electrons excited. This means that those electrons move up another energy level, which takes a lot of energy to do. But those electrons don't last in the excited state for a long time, so they essentially just take a quick dip at those higher energy levels and go back to their original level. Well, where do the protons come from? These electrons, when they go back to their original level after going up to a higher level, typically release photons, which is how lasers essentially work. Now, there are a few different ways for lasers to send information. One is through a fiber optic cable and the other is wirelessly. But since we are talking about laser transmission and reception, we will only talk about the wireless process. Lasers send information wirelessly, similar to how infrared sends information, through the use of a transmitter and a receiver. Now, there are different parts for each system, so we will discuss them separately. Laser transmitters are similar to usual radio transmitters in terms of their uses. They both send the information to the receiver. In this case, the laser transmitter fires up a beam to the receiver for it to decode something and output into something. Let's first talk about the laser component. So what actually is inside it? Well, the component contains a power source called pump, which is mentioned earlier. It also contains a lacing or gain medium, which is where the electrons come from, and where the actual optical gain comes from too. And the last component is the optical resonators. Well, that's cool, but what will its use be if there's nothing to receive it? Well, that's where the laser receiver comes in. So similar to a radio receiver, it essentially receives the beam from the transmitter and decodes it into the signal required to output, well, something. So, the system consists of a photodiode, an amplifier, if the system requires amplification, and the output itself. So first, let's talk about the photodiode. What is a photodiode? It essentially is a semiconductor, specifically a p-n conjunction semiconductor. So, photodiode works by absorbing photons and converts it into an electrical current or a signal. So depending on what you're gonna use it for, it may contain specific filters, lenses, or generally bigger and has a wider surface area. But wait, where does the signal come from? Because essentially it's just a beam of light. How can you possibly read something from that? Well, similar to how radio transmitters modulate either the amplitude or the frequency, laser transmitters modulate the same current that fires up the laser itself. So essentially you have a beam of light that differs in intensity, so the receiver has something to read. This is called direct modulation. There are a lot of things that use laser technology, from communication to the medical field to the different industries of production. Starting from communication, it has innovated data and information communication into another level by outperforming different wireless communication processes by both speed and density. One example of this is NASA's space communication with their satellites. They were using radio waves before, but proved to be very inefficient and power hungry, while laser is almost 100 times better in all ways. It was more efficient, sending more data in lesser time with more accuracy, and it's also very clean in terms of power usage. Next is in the medical field. It had helped many procedures that require pinpoint accuracy and different methods of detection, especially in the eyes. Because of the properties that laser beams contain, it can essentially pass through different materials easily when no other waves can. Well, how about in the industry of production? Well, thanks to its pinpoint accuracy, it has paved the way from machine cutting to being more accurate than the human hands, and much faster too. There are a lot of things that laser tech has helped and that we will not be able to cover in this video, but those are just the major ones. Well, even though laser technology has been used and is still being implemented in our everyday lives, it can still improve. We can still use laser technology to improve wired communication to be faster and better. By using fiber optic wires, we can improve wired communication because, let's face it, there's still advantages for wired compared to wireless. So, if we can implement the speed and density of lasers into wired communication, we'll be able to enter a whole nother level again. Well, that was fun, and quite educational if I do say so myself. But that's just the beginning of how far we've come in terms of technology, and how much more there still are that we haven't discovered and probably never tried out yet. Technology evolves rather quickly and may be too fast for us to keep up, but through the help of these kinds of videos and other media as well, we can learn all the bits that make up that incredible technology. Well, looks like that's all. As always, thanks for watching, and I hope to see you stick around again. Bye!